we're going to start by chatting about algebraic expressions. Okay, now, again, we've spoken about all of these things before. If you want to go and get these videos, remember we did this course at the beginning of term 3. So all of the videos for algebraic expressions and equations are on Watobe's website. So you can get them there if you want the full course. This is really just like a crash course in this stuff. So if we are dealing with algebraic expressions, firstly, what we need to bear in mind, let's just get a highlighter going here. What we need to bear in mind is that an expression will have the instruction simplify. Simplify because it's not an equation, so there won't be an equal sign. And so all we're trying to do here is look at the terms that we have and see if we can make the expression simpler. And so in order to do that, we need to be able to identify our terms. Now remember, terms are separated by plus and minus signs. So that is what you need to look out for when given an expression. You need to look out for the plus and minus signs so that you can identify your terms. Because if we can follow these 3 steps in terms of simplifying expressions, you should be fine to simplify any expression that I give you. So the 3 steps are to identify what terms you're working with in your expression. If you need to simplify each individual term, the second step won't always be necessary. Sometimes you will have to, sometimes you don't have to, but just double check whether or not you need to simplify your individual terms. And then finally, once you've simplified your individual terms, all we need to go and do is then add or subtract our like terms. Now, can someone, maybe you can put in the chat or you can raise your hand, can someone remind me what like terms are? What do I sort of look out for when I'm talking about like terms? I know you guys know this. What are like terms? Come on, Nasha, what are like terms?
So like terms are the terms that contain the same variable which is raised to the same power.
Excellent. So terms that have the same variables, it would also help if I could spell, and the same exponent. You said it much nicer than me. You said raised to the same power, which is absolutely fine. And the same exponent, or you can say raised to the same power. I actually like that more, but here we are. Okay, so very importantly, exponents. We are looking for terms that have the same variable or combination of variables with the same exponents. The numbers in front, i.e. the coefficients, can be different. It is the set of variables or variables and exponents that we look out for when we look for like terms. So that's what we need to be able to identify according to step number 3. And firstly, what we want to do is identify how many terms make up our expression. So if we have a look at question A here, can anyone, you can just pop it in the chat, how many terms do I have in this first expression of 7xy plus 3xy plus 5xy? How many terms are there? Nice, guys, well done. So I have 3 terms here. The plus and the minuses, in this case, just the pluses, separate my terms. So I've got 1 term, 2 terms, 3 terms. And so I've got a 3-termed expression that I'm working with here. Obviously, then I took everything off. Okay. Next thing I need to do, so I've done step 1, I've identified the terms that make up my expression. The next thing I want to do is I want to simplify each term. Now, like I said, we don't always have to do this. Sometimes this is already as simple as it can get, and I just can move on to adding or subtracting my like terms. And if I look at question A, that's the case. I'm not dividing any of these terms. I'm not distributing anything into brackets. I'm not multiplying anything. So in terms of simplifying each individual term, that has been done for me. There's nothing more I can do with the individual terms as they stand. What I can do is I can now start seeing, do I have any like terms? So again, you can just pop it on the chat. Are there any like terms in this expression? And if you think yes, what are the like terms? Theo says yes. Okay, good, Theo. So our like terms that we have here are the terms that contain X and Y. Now that's actually all of those. So remember, it's the same variables. Oh, golly, Miss Molly. Same variables with the same exponents. The exponents here, we don't have to stress too much about because they're all in exponents of 1. But all of these terms have the variables X, Y. They're all exactly the same. And so that means that all of these terms are like terms. And so I can now go and just add or subtract them. Now, in this case, I'm just adding. I don't need to worry about subtraction. When I add and subtract like terms, and I'll put this little note here, Nana, the exponents never change. The exponents only change when we multiply or divide, which we'll deal with in a second. So because I'm adding or subtracting, the exponents are going to stay to the power 1. So this is going to stay x, y. And then as Theo has said, 7 plus 3 plus 5 is then 15x, y. So very importantly, when we add or subtract, we don't change the exponents. Yo. Thank you, I'm an English teacher. Right, so add or subtracting, so dealing with like terms, the exponents are not going to change. That's very important to remember. Right, if you want to take a screenshot of this beautiful mess, there you go. I've just put it so that you can see all of it. And then we're going to have a look at the next one where we are going to have to do that second step. Okay, I'm hoping we've all got our screenshots. I'm going to scroll on down now. Right, so if we have a look at question B, we want to follow those 3 steps. Identify the terms, simplify each term, simplify the expression. So my first question to you is, how many terms do I have in this expression? You can put it in the chat if you want. How many terms am I working with here? Remember what separates terms. Okay, so remember, terms are separated by plus and minus signs. So have a look at question B again. Whoopsie daisies. How many terms do I have here if terms are separated by plus and minus signs? Nice, guys. Well done. So we only have 2 terms here. This plus separates my 2 terms. Multiplication has nothing to do with terms. This is where the simplification of terms comes in. So I've got term 1 and I've got term 2. Only 2 terms that I need to stress about here. And now I've identified my terms. So step 1 is done. Step 2 is to simplify each term. So if I look at these terms, I still need to go and multiply the 2x squared by the x and the 3x squared by the x. That is what simplify each term means. If there's multiplication or division that needs to happen, do it. Now, I feel like most of you are probably sort of comfortable with doing this in your head, but if you're not, that's absolutely fine. What we want to do is we want to sort of do this multiplication. I wish I could draw a line. Oh, so much better. We want to do these multiplication steps. So term 1 was 2x squared times x, and term 2 was 3x squared times x. Now, what we can remember here, some of you might remember this, but if you're new, some of you might remember S and V. This is sort of a little trick to remember how to multiply correctly. So we start by dealing with the signs, then we move on to the numbers, and then we move on to the variables. And now this is where we need to be careful. If I'm multiplying 2 variables, the exponents can change. And again, I'll make a little note of that in a second. So let's do the first multiplication. I've got a positive times a positive because it's positive 2x squared times positive x, which means that my answer is going to be positive. I obviously don't have to write the positive there. I just need to deal with the sign. So I've got positive answer. I then deal with the numbers, which is 2 times, and we know that there's a 1 in front of this x, so 2 times 1, which is just 2. And now I need to remember that when I multiply variables, my exponent laws need to come into play. And so x squared times x is x cubed, because remember, I add the exponents together, and that x has an exponent of 1. So this very first term is simplified to 2x cubed. This simplifies to 2x cubed. And now I'm going to do the same thing with the second term. So you can quickly put it in the chat. What is 3x squared times x? What do I get when I say 3x squared times x? Good, Rebetsway. We get, oh, close, careful your exponent, well done. We get 3x cubed. Positive times a positive is a positive. 3 times 1 is 3. X squared times x is x cubed. And so I've got plus 3x cubed. So now I've done step number 2, where we have simplified each term. Now I want to check if there's any like terms to this expression that I can add together. So I'll give you a second to think about it and let me know if you think there's like terms, and then give me a final answer. Whoops. Yes, if Theo's put an answer on the chat. I don't think I've spelled anything right there. Let's just look, yeah. Change exponents. I got there then. So that's just a little note to remember that when we times or divide variables, the exponents will change. Theo's put an answer on the chat for us, which is very close. Remember, we're now adding like terms because both of these are x cubes. Both of these terms are like terms with each other. Remember, when we add and subtract, the exponent doesn't change. So this is going to stay x cubed, but 2 plus 3 is 5x cubed. I'm not multiplying, I'm adding. And so 2x cubes plus another 3x cubes gives me 5x cubes. Right, so very importantly to remember that when we multiply or divide with variables, the exponents change. But when we add or subtract, the exponents don't. And this is 5x cubed because I'm adding 2 plus 5. All right, so I'll leave it up there if you want to take a screenshot. Right, let's have a look at C. Andrew's on it. If we have a look at C, again, we want to know how many terms we're dealing with here. But importantly, the plus or minus signs inside a bracket, we don't consider when considering how many terms are in the whole expression. So here, I actually just have 2 terms in this expression. Now, importantly, there is multiplication that has to happen. I need to distribute the 5 into the first bracket and the 6 into the second bracket before I start adding or subtracting like terms. So I want you to try this by yourself. I've given you a hint of where to start. Andrew's already on it, but give it a go. Do your distribution, collect your like terms, and then give me a final answer. If you want to explain it, you can raise your hand, but give example C a try for me.
Wow, I already see some hands being ready. Let's go, my babes.
I'm just going to give everyone another minute or two to finish off, but I do see those hands. Very nice. Okay, Theo, do you want to explain it to us?
So, ma'am, I said 5 times 2x, then I got 10x plus 5 times 3y, then I got 15y,
Good.
and I plus 6 times x, then I got 6x plus 6 times y, then I got 6y.
Good.
Then I checked for the like terms, then I got 10 plus 6x plus 15 plus 6y, which is 16x plus 21y.
Excellent. Well done. Thank you, Theo. Oh gosh, it's gone weird. Okay, guys, so exactly, we distribute, just so that we're all here where these things are coming from. If I distribute the 5 into the first bracket, I get the 10x plus 15y. And if I distribute the 6 into the second bracket, I get the 6x plus 6y. So that's where those terms have come from. I can then collect my like terms. Now, I quite like what Theo's done here. If you want to write the like terms together and sort of group them before you add them, go for it. If you are happy to just see where your like terms are and go straight to a final answer, that's also absolutely fine. Whatever works for you. But we collect our like terms and we add or subtract the like terms that we have. And so we end up with a final answer of 16x plus 21y. Very nice. Well done, guys. I'll leave it up there for you to screenshot. And then we've got one more and then we're going to have a break. Right, so the next one we need to read very carefully. So question D is saying to us, subtract 5a minus 4b plus 10c from 6b minus 3c plus 4a. So we can almost think of this as saying, if we like sort of make this much simpler, subtract 3 from 7. So imagine this expression said 3, that expression said 7. What that's saying to me is take 3 away from 7. So 7 minus 3. And this can work with anything. If I say subtract 2x from 5x, I'm saying take 2x away from 5x. And so it's so important to read this correctly because the order in which I'm going to work with this or put this into form an expression is very important. So when I set up my expression for myself, I want the 6b minus 3c plus 4a first because I want to take away from that the second expression, which was 5a minus 4b plus 10c. Now, importantly, I have to put it into brackets because remember, I'm subtracting. The second I'm subtracting there is that -1 in front of a term or in front of a bracket that needs to distribute to all 3 terms in my bracket. Right, so I'm hoping this makes sense. If it doesn't, please ask. But I want you to go and subtract those 2 expressions and tell me what you get. If it isn't making sense, let me know and I'll try and explain it again. But because we've been told to subtract the first one from the second one, the order that I write them is very important. Okay, so Theo, if we have been told to subtract something from another expression, so just ignore the first one for a second and let's look at these two. If I told you to subtract 3 from 7, what essentially I'm saying is take 3 away from 7. So 7 minus 3. If I said, English, if I said subtract 2x from 5x, I'm saying take 2x away from 5x. So again, 5x minus 2x. And so if I look at my sort of original question, I'm saying take this expression away from the second expression. So take 6b minus 3c plus 4a and minus the 5a minus 4b plus 10c. I want to take the first expression away from the second expression. So it needs to be the second expression minus the first expression, just based on what the sentence is saying to me. I hope that makes a bit more sense. Hopefully. It is a tricky one because of sort of the words and the language here, but it's telling me to take the first one away from the second one. So it should be the second expression minus the first expression. Good. Right, guys, now remember you've got A's, B's, and C's, so your answer should have A's, B's, and C's there as well. And like I say, do the distribution of the -1 to all of the terms in the bracket and then see where you end up.
We can do this, my babes. Let's go. Good practice.
If you want to give an answer or you want to explain, you can raise your hand. Otherwise, you can just put it in the chat. I'm going to give you another minute or so. Nice. Hey, Roberto, do you want to raise your hand and explain it? I'm just picking on you because I can see you've given the answer. If you don't want to, that's absolutely fine. Wonderful. If you raise your hand, I'll be able to unmute you. Awesome. Okay, Roberto, tell us, how do we do this?
Hi, ma'am.
Hi.
So, ma'am, firstly, the first part of the expression will stay the same.
Excellent. So this part.
Yes, ma'am.
Okay, cool.
So then we will multiply the negative by 5. Since 5 is a positive, we will get a negative because a negative times a positive is a negative.
Excellent. So we end up with?
Negative 5a.
Perfect.
And then a negative times a negative is a positive. So we'll get positive 4b.
Good.
And then we'll get negative 10c.
Perfect. For exactly the same reason that Roberto had told us for the negative 5a. Perfect. Okay, what next?
So, ma'am, for the next step, you'll be grouping the like terms.
Okay, cool. I'm just going to go up here where I've got some space. So what should I write down?
6b plus 4b, negative 3c minus 10c,
Good.
and then positive 4a minus 5a.
Perfect.
So, ma'am, for 6b plus 4b, I got 10b.
Good.
And then for -3 minus 10, I got -13, and it took, because it took the sign of the bigger one.
Okay.
And then for positive 4a plus minus 5a, I got -1.
A.
1, yes, ma'am, sorry.
Perfect. No, that's perfect. Awesome. So guys, we've got -1a as the last one. If you don't want to write the 1 there, that's cool. We don't have to put the 1, but you're more than welcome to. And that is, oh, that was great. And that then is our simplified answer. Now, if you want to, you can write this in alphabetical order. So you can write this as -a plus 10b minus 13c, if you really feel that way. Often we do try write our answers in alphabetical order. You don't have to, but we do sometimes. In this case, I really wouldn't care if it was not in alphabetical order. So either one that you've written, absolutely fine. What you want in your answer is a positive 10b, a negative 13c, and a negative a. Don't care what order they're in, but it should be a positive 10b, negative 13c, and negative 1a. That's what you need in your answer. All right, so this, let's just do that, make it a little bit smaller. So if you want to take a screenshot, hopefully you've got it all there and you can get it all in. And then we're going to take a little break where you're going to guess the phrase of some of these things. They were quite tricky, but I have confidence you can do it. Alrighty. Last 2 seconds to take a screenshot. Let's have a go. Whoops. Right, so those 5 images, I want you to guess the phrase of the 5 images. Let's put a little blocky around it. So those 5 things, what is the phrase? Remember, it's like a common phrase that people often use in and around life. You can put your hand up or you can pop it in the chat. What phrase do you think we've got? Honse, which one do you think?
Ma'am, I'm going for number 2.
Mm-hmm.
Number 2, I think it's baseline.
Wonderful. Baseline. So like I really want to say a rugby field, but I don't actually know if there's a baseline of a rugby field. Tennis, there are baselines. Not sure if there's a baseline in soccer, but baseline. Agreed. Well done, Honse.
Thank you, ma'am.
Paul also got, Sherbet got number 4 in the chat. Well done. Number 4 is a hole in one, because there's a hole in the number 1. Wonderful. Guys are on it tonight. Kanya, excellent. Number 1 is midday tea, if that's something you do. The other class also struggled with the last 2. I'll give you a hint. The struggle is going up. And the eyes are all high up in the block, and there's a line of them. Those are my clues. So the struggle is going up, and the eyes are high up in the block, and there's a line of them. Atlile, very close. High is part of it, but it is not the only thing. So high something. And it has to do with the eyes and the line. Not the struggle is real. All very good suggestions, but not quite. Think about the eyes in the line.
Yeah, you guys are getting there. Don't worry, I also didn't get this one. I struggled.
If something, like if you are waiting in a line, what could you also say you're waiting in? You're waiting in a? Okay, Becky, nice. So if we've got a queue of eyes and I've said there's a high, well done, Samuel, a high IQ. Wonderful. So we've got the eyes that are high up in the corner, and it's a queue of eyes. Well done. High IQ for number 3. We've still got number 4 to go. Remember, I told you that my clue there was it's going up. Have I stumped you with the last one? It's a something struggle, and the something has to do with the upwards direction. Close, Lisejo. Add a little bit more to your ups. What's the expression when, like, we talk about a struggle that just seems, well done, Alan, an uphill struggle. Right? It's an expression that we sometimes use when, like, it's just like one struggle after the next. It's an uphill struggle. We get through it in the end. Very nice, though. Well done, guys. We got those first 3 nice and easy. No, 1, 2, and 4. Well done. I don't know if anyone wants to take a screenshot of this. I don't know how we feel about this afterwards. Okay, but let us have a look at some equations. Okay, because equations is part of algebra. We sort of have to use some of our concepts of simplifying expressions when solving equations. But there are some important things that we now need to remember in addition to when I solve equations. Okay, so when solving equations, there's 2 important things we need to remember. Firstly, when solving any equation, what is very, very important to remember is that we have to use inverse operations. The reason we have to use inverse operations is because this is an equation. What I'm doing on one side of my equation, so if I'm adding something to one side of my equation, I have to do on the other side, which is why we need to do these inverse equations on both sides of the equation. Because if I subtract 2 on one side and don't subtract 2 on the other side, it's going to sort of disturb the balance. And so I need to remember that when I'm doing my inverse operations, I need to do it on both sides of my equation. Right, so that's very important to remember. Now, the goal of solving an equation is to solve for the variable. So in all of these, we're going to solve for x. And so what we basically want to do is get x alone. So if you guys have a look at the first one, who wants to give me a suggestion of what my first step could be here in order to start solving for x? Where can I start? You can raise your hand or you can put it on the chat. Becky, what do you think?
Ma'am, I think you would bring the 2 over the equal sign to the
Okay, and what's going to happen to it?
It's going to become a -2.
Excellent, well done. So this is where we're talking about those inverse operations, guys. I want to get x alone. So the first thing I want to deal with is this +2. I use the inverse of that, and I will go and subtract 2 on both sides. Now, you don't have to write this step as I'm writing it. If you are comfortable to just subtract 2 on both sides and write down the answer, that's fine. But exactly as Becky said, we want to subtract 2 on both sides. On the left, plus 2 minus 2 means that I've got 0. So I've just got 3x. And negative 10 minus 2 gives me a negative 12. I'm taking even more away from something that's negative. And now I've just got the x term on the left. Becky, do you want to tell me what the next thing I could do is?
Ma'am, you can put it into a fraction.
Okay, and what will my fraction look like?
Ma'am, it will be 3x over 3 and negative 12 over 3.
Excellent. So guys, the next thing I want to deal with is this coefficient. I don't want 3x, I just want x. So by dividing both sides by 3, and remember it's my inverse operation, it was originally 3 times x. So the inverse of that is to divide. By using that inverse operation, I'm going to get x alone. So the 3's essentially cancel and leaving me with x on the left. Now, importantly, when we divide, we've got a negative divided by a positive, which is a negative, and 12 divided by 3, which is 4. And so I have gone and solved for x in this equation. I just want to move this up because, oh, maybe I don't want to move it up. There we go. It's fighting with me. All right, there we go. And so we get that x is equal to negative 4. Now, what's really important for you to remember is that you can check these answers. You don't have to write out the check, and I wouldn't suggest you do it unless you're told to check your answer. But I would suggest that when you get to the end of your exam and you maybe have like 5 or 10 minutes, you go back to your equation section and you check your answers. Your check is to make sure that the left-hand side is equal to the right-hand side, because if the left is equal to the right, it means that the equation is true. 5 is equal to 5, or negative a half is equal to negative a half. That's a true statement. And to do your check, we take our original equation and we substitute in the value for x that we got. So I'm now going to put x equals negative 4 and substitute it in. So I'll have 3 times negative 4 plus 2 should equal negative 10. A positive times a negative is a negative. 3 times 4 is 12. So negative 12 plus 2, negative 10. And negative 12 plus 2 is a negative 10, because I'm adding 2 to something that's negative. And I've got negative 10 is equal to negative 10. Now that's true. Negative 10 is equal to negative 10. And so my left-hand side is equal to my right-hand side. But again, this check I would do just on my calculator. You don't have to write it down. Check that the left is equal to the right so that you know that the answer you've gotten for x is correct. All right, so take your screenshots. What I'm going to do is I'm just going to move this up a little bit. And I'm going to ask you to try English. I'm going to ask you to try question B for me by yourselves. So I want you to solve for x. X can be on the left or the right-hand side of your equation. It doesn't matter. As long as you get positive 1x alone, you have solved the equation. So I want you to try B for me. You can put your answers in the chat, or you can raise your hand if you want to explain it to us. But find an answer for B for me. And I'll leave A up there just that you can see what we're doing. Remember your inverse operations, and remember we want x alone, positive 1x alone. Make sure you're dealing with your signs correctly. And remember, if you're not sure about your answer, substitute it back in to check that the left is equal to the right. Yes, guys, I'm seeing some good answers coming through there. Becky, do you want to explain it to us?
Ma'am, I got -4.
Okay, so do you want to explain how you got your answer? Let's see.
So I said -4 minus 8 equals 3x.
Okay, so careful, it's -3x, hey?
Yes, ma'am.
Okay, cool.
And then I got the answer, which is -12 equals -3x.
Perfect. And then what do I need to do?
You need to divide
By what?
-3.
Perfect. Okay, so we're going to divide both sides by -3. So what is a negative divided by a negative?
Ma'am, it's a positive.
Perfect. And so what is -12 divided by -3?
4, ma'am.
4, exactly. Well done. Right, so guys, in this case, x is equal to +4 because of that negative divided by a negative. Now, it is absolutely fine for you to write your answer as 4 equals x. It means exactly the same thing as x equals 4. If you want it to look sort of, or to have the x on the left, that's fine. You can reorder it, but it means exactly the same thing. So it doesn't matter however you want to do it. And that's why I said it doesn't matter if you put the x on the left or on the right. You will get the same answer. What is important, and just I can see Samuel's comment there, where we often go wrong is we forget signs. We either forget to put the sign in, or we forget about a positive divided by a negative as a negative. Whatever the case is, often where we go wrong is just signs. And so make sure you're double checking yourself as you go along. I don't know how many of you write down the question and then do your answer, but if you write down the question first, make sure you copy the question correctly. I've often had kids copy the question down incorrectly, and then I can't give them marks because they haven't actually answered the question. So just always double check yourself. Okay, so I'll leave that up there for a second for you to take a screenshot. And then we'll have a look at another one.
Let's do this, my pibs. We can do it.
Okay. Right, so here we've got question, I think you can probably try both of these actually. Question C and question D. So I'll talk through them a little bit just because I know it was a while since we did equations. Question C, we've got a fraction. And so what we need to remember is that the inverse of division, which is what a fraction tells us, is multiplication. So if I want to get rid of that denominator, which I do, I need to times, I need to do the opposite. In question D, I can see that there are brackets, which means that I have distribution that needs to happen before I start stressing about anything. So I need to first distribute the coefficient into those brackets before I start stressing about my inverse operations. So those are my two hints. Hint number one for question C is to get rid of a denominator. We do the opposite, so we times. And question D, do the distribution. Okay, so give it a try. When you have an answer, you can put your answers in the chat with C and D. And then if you want to raise your hand and tell us how you did it, you can do that and we'll get you to explain how you did them. There's a child screaming in the street. Theo, I'm liking C, double check D for me. Good. I'm going to give everyone another minute or two. And remember, guys, if you're sitting and waiting, check your answers. Substitute in and make sure that the left is equal to the right. Good, I'm seeing some excellent answers coming through. Remember those inverse operations. And remember, we want positive 1x, just x alone. Okay, I'm going to give you another minute and then I'm going to get some answers. So make sure you raise your hand if you want to give me some answers. You can see Theo's hand is up. Okay, nice, guys. Okay, so Theo, you're going to do C. Emmanuel, you're going to do D. Right, Theo, give us C.
So ma'am, I said 2 minus x divided by 5 equals 3. Then I said 3 times 5.
Okay, cool. So we're going to times, going to times both sides by 5 because that's going to get rid of that fraction. Perfect. So what do you have?
Then I got 15. Then I said minus x equals 15 minus 2.
Okay, sorry, I'm catching up. Okay, cool, yeah.
Then I said then I got 13 and minus x. Then I said minus x divided by minus 1 equals 13 divided by minus 1. Then I got x equals 13.
Perfect. Oops, 13. Okay, so guys, what's very important there is the fact that we've got a negative 1 in front of the x, and I don't want that. So we have got a negative 1 coefficient. I don't want that. That's why I divide by a negative 1 on both sides in order to get a positive 1x. And once I've done that, I end up with my final answer of negative 13. Okay, so first thing, to get rid of the fraction, I times both sides by 5. That gave me 2 minus x equals 15. And then it's just a nice, easy equation that I can go and solve for. The only thing we need to bear in mind is the fact that it's a negative x. So don't forget to make it a positive by dividing by the negative 1. Alrighty. Okay, Emmanuel, D.
Ma'am, so I said 3 times x gave me 3x, and 3 times 2 gave me plus 6, and 2 times x gave me 2x, and 2 times 1 gave me 2.
Good.
And then I said I moved 2x over to the side of 3x, so I got a negative 2x.
Good.
And I moved the 6 over to the 2, and I got a negative 6.
Perfect.
And 2 minus 6 gave me negative 4, and 3x minus 2x gave me x, 1,
Perfect.
basically 1x.
1x,
Yeah.
perfect. Okay, guys, so that's it. We distribute. Please remember that you're distributing the coefficient, so the number in front of the bracket, to both terms in the bracket. If we don't do that, we're going to have weird terms. And once we've done that, we can then go and do our inverse operations. Now, I'm hoping we all understand the step over here that I'm highlighting in yellow. So what Emmanuel did was he subtracted 2x on both sides to put the 2x on the left, and then subtracted 6 on both sides to essentially get the 6 on the right. Obviously, if you need to do steps before that, by all means go for it. But if you're comfortable to do it like this, then that's absolutely fine. But at the end of the day, for this final answer, we get x is equal to a -4. Okay, so I'll leave this like this in case you want to take screenshots, and you can get both of them English. All right, and then we're going to end off with E, which is one that sometimes throws us a little bit. All right, so I'm going to do a bit of an explanation, but then I'm going to get you to do it by yourself. What I want you to notice here is that you have got two terms on the left-hand side. So you've got a term 4, and then you've got the term -2 times x minus 3. And what that means is that we first need to distribute this -2 into the bracket, because remember, it goes back to expressions. If I've got multiple terms, let me simplify each term before I do anything else. So I first want to distribute that -2 into the bracket before I start solving my equation. So that is sort of me telling you what step number 1 needs to be. Try question E for me. Put your answer in the chat once you have one, or you can raise your hand to explain it to us. But the first thing you need to do here, because you have two separate terms on the left, is distribute in the -2. And then obviously we're solving for x. Sorry, guys. And I could say once you've done your distribution, you can then go ahead and deal with those inverse operations. Very importantly, you are not saying 4 minus 2, you are first distributing in that -2. If you do 4 minus 2, you've missed the boat. I'm going to give you another minute. We're getting some mixed answers here, and then we'll go through. Okay, guys, we've got a bit of a mixed bag here, so let's have a look. So I'm just going to take off the scribble just to start off with. Remember, the 4 and the -2 times the bracket are two separate terms. So I need to deal with them separately to start off with. What that means is that the first thing I want to do is take the -2 and distribute it into the bracket. What that means is the 4 is going to stay there for now. I'll deal with it in a second. -2 times x is -2x, and -2 times -3 is then +6, which means we get 4 minus 2x plus 6 is equal to 8. Now it's completely up to you how you then go about this. I can see that the 4 and the 6 are like terms, so I'm just going to neaten up the left and add them together. which means I've got negative 2x plus 10 is equal to 8. And now I'm going to start with my inverse operation. So the first thing I want to do is subtract 10 on both sides. So I've got 8 minus 10. We know that 8 minus 10 is a negative 2. And so what I now want to do is essentially divide both sides by a negative 2 in order to get x alone. And we know that a negative divided by a negative is a positive, and 2 divided by 2 is 1. And so we end up with x is equal to 1. Right, so very important there is that we first do the distribution of this negative 2, because that is what needs to happen in term 2 in order to simplify it. And only from there do we start doing our inverse operations. Right, so I'll let you take a screenshot and then you can do the poll before you leave.